Hello everyone, good day to everybody, and this is Zubair Al Qureshi on my YouTube channel, that is Network Lessons. And today in this video we are going to learn the basics of MPLS, how the MPLS works, okay, and how you need to set up MPLS, okay. And one of the use cases of the MPLS, that ISP, the service provider, right, that are using in their core, right. So we will learn how all this works and how to set up a lab from scratch. So let's begin. So in this lab I'll be using 6 routers, right. You can see 6 routers, and so the core would be this one, okay. This will be my ISP core, service provider, okay. I'll be using internally, there should be an underlay protocol running, so mostly they use IS, right, but for simplicity I'll go with EIGRP because most of the guys who would not know ISIs, right. So I'll use EIGRP as the internal routing protocol, and then I'll use BGP AS100, okay. And then I have the other sites. This site will be using BGP with AS600, as you can see, and this side would be using AS500, right, BGP. So first of all, our first step would be to configure this ISP core, okay, and then run MPLS on it. And I'll show you how the MPLS works, and based on that I'll explain to you step by step, right. So let's configure the R1, R2 and R3 and R4 for the basic IP address schema, right. So let's begin with R1. So what I need on R1 is I need okay, let me just see if my OT has started. Yeah, I need to press no on this, and this one as well, this one as well, R3, and then I have R4, right. Okay, so this is my R4. Okay, let's go to R1 again. R1, yeah, R1 is up. So first thing first, what do I need? So I'll do one thing. I'll open a notepad and I'll type the commands in it. Okay, so basic commands. We'll save them. First enable, then you have config t, then you have host name. This is R1, right? Then we'll do a write. Okay, then I have which interface? Then I have interface Ethernet 0/0, right? 0/0, and the IP address for this is 192.1.12.1 255.255.250. So then no shut, because see, you can see this is between 1 and 2, so 12, and then R1 will have the 1 IP, right. Then I need to have a loopback, interface loopback 0, IP address would be 1.1.1.1, and I'll keep this as /8, right, /8 255, okay, 255, right, and done. Nothing else. This is the basic connectivity. I'll not run the EIGRP and all. I'll do that, and before that I need to run here no IP domain lookup, because sometimes what happens is we type the password, some commands, right, wrong commands, so it takes time. So this is R1, and I'll do the same for R2. Copy R2, and R2 would be what, R2 and config 2. This is R2 Ethernet 00 it needs, and this should be 2, and it needs another interface E1, right, E/1 that has 193.23.2. So this is 23.2, and then the loopback address is 2.2.2.2. Okay. Using Notepad, Okay, R1, R2, and I missed one Ethernet 00, right? So I'll copy this. 23.2 is for, okay, 12.2. So using a notepad is very convenient, right? So I don't have to type the commands again and again on the router. So R3 would be interface E00 would be 23.3, right? Yeah. And E00 towards R4 is 34.3. 34.3, and the loop back is 3.3.3.3, right? And then we'll configure R4. Okay, let's go to R4. Let's do it real quick. I think I'm not changed the host name to R3, right? Yeah. So you need to be sure not to do all this, and then E00 I need to configure, right? E00 is 34.4 for R4, and I don't want for now I don't need this E01. So loop back would be 4.4.4.4, 4.4.4.4, right? So okay, then I'll do a write. Okay, then let's do a end and then write on every router, so that saves the configuration, right? It saves the configuration. And okay, done to R3. Now I need this on R2 and then R1. Okay, we're done. So let's paste this on all the routers. Let's start with R1 and I'll paste it here. Done. And let's go to R2. R2 is here, from here. Let's do it on R2. Fine. And then enter on R2. And then now I have R3. And R3. Let's go to R3. Is the one, yeah. Then last one is R4. Okay, let's go to R4. Okay, so from R4 I should be able to ping the R3's E01, that is the directly connected neighbor, right? So ping 192.1.34.3, that is but directly connected neighbor. So this is what you need to check, right? Show IP interface brief. So I can see, oh, I missed E00 on R3. How come? R3 interface E0. I have put, oh, that is 23, is it? E01. Okay, my mistake. So this is what you have to be careful, right? R3 34.3. I think some problem is the IP address. Okay, IP add. See, so IP add, everywhere I have problem here. So that means IP add, right? IP add. So here also add. Uh, oh my god, you guys should have told me, no? Okay, let's do it once again. R1. Next is R2. Oh, oh, R2. This is the R2. And next is R3. Where's R3? R3, right? This one. And then R4, right? Last one. Okay, R4 is this one. Okay, let's ping again. Ping 192.1.34.3. That should be the next hop neighbor. Okay, great. And from R3, I'll ping my R2 interface, that is 23.2. And from R2, I'll ping R1. Ping 192.1.12.1. So these are my, okay. Let's check for the loopback. Show IP interface brief. I should have 2222. Here also I should have 3333, and here I should have 4444, and on R1 I should have 1111. So that is there. So now let's run EIGRP on all the routers so that the loopbacks would be reachable on every router. Like from R1 to R4, I should be able to ping uh, this with the source back of loopback 0. This should be like reachable, right? So for now it's not reachable because I don't have any route. So let's run what do you say? Let's run EIGRP. Configure EIGRP on all routers and R1 and R2, R1 and R4 only on the inside interfaces, right? Got it, right? Inside interfaces. That means the interfaces that are inside the ISP side. So it will not run on E00, will not run on E00 here. So let's go and configure this on this. So for R1, right? R1, what we will do is router. First of all, config T. Then we have router EIGRP. So this would be 100. Then we will do no auto summary, right? Because it will auto summarize by default. So no auto summary, and then I will have the network command. Network. I have one, and then I have network. Sorry, 192.1.12.0. Done. That's it. Then I will do end and then write. Okay. So this is R1. Let's do the same for R2. R2 is config T and this would be 2 and this would be 20. Okay, 12 would be there, correct? And then I would have 23. So I will copy this, paste it here and make this 23, right? On right left. And then I will have R3 likewise, R3 and 100, and this would be 3, and 192.23 would be there, and then 34 would be there. And then last not least I have R4, right? R4 we will have the 4 loopback and then the 34, right? So after that end and then right. So let's copy paste all this configuration on all the routers. So let's start with R1 done. R2, as soon as I paste this on R2, the neighborship between R1 and R2 should come up, right? So we can see there is neighborship with R1 and R2. Let's do this on R3. R3 done. There should be a neighborship with R2, right? And R4 done. R4, yeah. And neighborship with R3. Okay, so let's check on R1 show IP EIGRP neighbors, right? Okay, neighbors. So I can see I'm neighbors with R1 is neighbors with R2, right? So R2 will be neighbors with two routers, R1 and R3. Show IP EIGRP neighbors, right? Okay, so I can see. So let's check on R1 that I'm having the loopback. I am having that reachability, right? Show IP interface. No, show IP route. That is the global IP routing table, and I can see I can reach 4 via 2, right? So let's try that thing that we did earlier and we were not successful, right? Source of loopback 0, right? So that is done. Okay, so now the most important part, right? So how do you think this traffic is going from R1 to R3? Sorry, R4. So let's grab my pen and see. Okay, so here's the pen, and from when we type ping, right? Ping 4.4.4.4 with a source of 1.1.1.1, right? Loopback 0 is 0. So what happens on R1 is it generates a packet, right? It creates a packet with source and destination, right? So source and destination. source is 1.1.1.1 and destination is 4.4.4.4, right? So this is the packet that R1 creates, and and so we have this traffic, right? So what R1 does is it looks to the destination IP address. So it looks into its routing table, right? So I know this destination or not, right? I know this, right? And this is via what? Via R2, right? 192.112.1.2, and that is on Ethernet 00. So I'll send this traffic. Before this, actually, it looks into the Ceph table that has been calculated, right? So I'll show you the Ceph table here. Show IP Ceph. So you can see 444 is via this, and via Ethernet is this, right? 00. So likewise, what happens on R2 is same thing, and then the MAC address rewrite is done on R1, right? With the source MAC as the E00 of R1 and the destination MAC of R2 E00. And then again, R2 does show IP route. It gets the 444, it knows, and it sends it via show IP. Ceph has the layer 2 MAC address rewrite, and I know it's via 23, and then E00 sends it to R3. R3 gets it, show IP route, sees where is R4. Okay, 444 is on E01 via 34.4. Show IP Ceph gets the layer 2 MAC address rewrite, right? You can see, and R4 gets the traffic, and for R4 it's directly connected, right? Show IP or route, and 444 is directly connected, right? So this is how the traffic goes, right? But now we have to understand MPLS, right? So these all things are happening on layer 3, right? So one more important thing for MPLS to work, right? For let me grab a pen. For okay, let me delete this. For MPLS to work, right? You need IP Ceph to be enabled. Cisco and other vendors would have something similar to this, right? IP Ceph should be enabled. So you saw that on all my routers the Ceph is running, right? That is by default. So if you do no IP Ceph, then the Ceph will be disabled and your MPLS will not work. So second thing is MPLS generates labels. Okay, this is called multi-protocol label switching, right? So it uses labels. So you have the Ceph table, right? You have the Ceph table. With the help of Ceph table, it will generate labels for the corresponding routes. For example, in R1, I know 4.4.4.4, right? 4.4. So for this, R1 will generate a label, say 21, and the label starts actually from 16, and it's in millions, right? So it's a 32-bit size actually, the label size, 32-bit, like an IP address, okay? And then what happens is it generates this locally 21 and sends this to R2. R2 will have, say, remote label, right? Remote label, and remote label for 4.4.4.4, right, is 21, and it will have also a local label for the same 4.4.4.4, right? It'll say 30, right? But then when it sends to R3, R3 will have 4.4.4.4, okay, remote label as 30 from R3, right? From R3, and a local label again say 27, like that, and it'll again propagate to R4, right? So R4 will have for 44444, again a label. Remote would be 27 from R3, right? Sorry, 30 from R3, and local label something. Okay. Just to explain to you, the local label, right? If the route is directly connected, it will be unlabeled. I'll change this statement later on, but I want you to understand something, right? So for R4, 4.4.4.4 is unlabeled, and for R1, 1.1.1.1 is unlabeled because it's directly connected, right? So actually, it is labeled as implicit null, but I want you to understand something. That's why I'm saying this thing that is unlabeled. So for example, what happens in R1 is when we get a route for 44444, it checks the first, what it does the route lookup, right? It sees 4444444, and then that's the normal way, right? That's the normal way. But when you have this MPLS enabled, right? You remember the OSI model, right? OSI model. Okay, let me create this. So we have the physical, we have the data, we have the network, we have the transport, and then we have the application, right? This will keep it as an app. This is your transport, right? This is your network. This is your data link, and this is your physical. Okay, now do you remember? There's a field in transport layer that tells the upper layer what application to use, right? And do you remember what is that? These are the port numbers, right? Port numbers. And likewise, network layer has something. What is that? That tells the upper transport layer what to use. Is it TCP, is it UDP, or something else? That is the protocol number, right? So for example, for TCP, it will be, okay, this is TCP. TCP, it will be 6, right? Likewise, if it's EIGRP, 88, 89 for OSPF, like that. And then for data link, there is another field in the Ethernet, sorry, in the layer 2 header, right? What is that called? By like slip of the tongue happened, and I actually told the name. That is the ether type. Okay, ether type tells you on L3 what is the protocol that you are going to use. So for IPv4, we have this value, and likewise for MPLS, if I'm not like mistaken, 3847 something like that. Please check on that. That is for MPLS. So when the traffic reaches on R1, right, and the packet is created, the ether type will not be 0x0800, right? It will be 0x3847, which will point to MPLS, and it will not look for the routing table, that is the rib and the fib, right? It will not look into the fib. It will actually look into the, there is another thing called lib and l lfib. Okay, so this will this packet will look into the lfib. And how to check the lfib, I'll show you that. So let me just briefly explain the rib, fib, lib, and lfib, right? So you have the control plane protocols, right? OSPF. Sorry. we have OSPF, we have EIGRP, right? Like that. It helps us build the what? Rep, right? And Ceph builds the fib. Likewise, we have in MPLS LDP that builds the lib. And right, and then MPLS builds the alpha. Okay, so LDP is a protocol that is used in MPLS by default on all Cisco routers. They will be running LDP. It's a neighbor discovery protocol, so they will have neighborship in between them, right? Like this, they will be neighbors, LDP neighbors, and will exchanging the label, and they will exchange the labels. Okay, and these all routers are called the LSRs, label switch routers. Okay, so this is actually the PE, provider edge, that connects to the customer edge, right? Customer edge. So the PE actually does the uh, tagging, you can say, the labeling. And by tagging, I remember that Cisco used to use TDP also, tag discovery, label distribution protocol, tag distribution protocol. I'll show you that. Okay, but now LDP is the standard, so everybody is using LDP. So we can change that also. So what happens is this tags the traffic with the label, and this router R2, it does the swap, something called a swap, right? It has, for example, there's a traffic for 4444444, right? And it got the label, remote label as okay, it will actually get the remote label from here, so R3. You will see that R2 will have two labels, but then the decision is made by the routing protocol like the EIGRP, right? It will know it is actually taken from the fib, right? The best path. So a remote label would be from R3, for example, 38, right? From R3. Huh? So, and the local label is say 22. So it received from R1, say R1 had label for 44444 as what? As 33. So R1 sent the label to R2, right? And R2 also has a remote label of 33 from R1, right? So whenever it sees that this traffic is for what? Is for meant for R3, right? So it will swap. It will swap 33 with 38, right? It will send to 38 to R3. It will actually tag that packet, right? There's a tag actually here, label put in between. This is called layer 2.5. So 2.5 here it will be a tag of 38. So the source would be 1.1.1.1, destination 4.4.4.4, right? So that tag will be here 38. Once R3 received, R3 has the traffic, right? So for 4.4.4.4, again R3 will have some tag, local label, right? Local label, say it is 20, okay, so this time it would be 38 because this is my local label, right? So 38 I'll send to, whenever I'm sending a packet, I'll send to uh, either R2 or R4 from R3, right? So I'll send 38 to them. So when I receive 38, I know that the remote label from R3 is 22, right? So this thing 22. Likewise, I will have a remote label from R4, right? In this case, it will be implicit null, but say, for example, I have some label. I'll just make you understand why we have implicit null. So in this case, it will say we have so this implicit null thing is not okay. So for example, say we have a label from R4, right? Say 2031. So here what R3 would do, he received 38, but the traffic is for 444, and I need to send it to R4, right? R4 has sent a label of 31. So I'll again do what? Swap the label, right? So I'll change this 38. I'll change this 38 with what? With 31. And I'll send it to R4. R4 will check the first thing it does the okay. See, I'll try to make you understand here why I will show the label and implicit now. So that way you will understand. So when R4 receives, right? R4 receives a packet with a label of 31, right? What it'll do, it'll look into the lfib and it'll come to know it's unlabeled, right? And then it will check into the fib, right? The L3 table. So here it did a label check, and then it has to do a fib check, L3 check, and then L3 it will see that this is a directly connected route, right? Loop back. So here R4 had to do two lookups, the lfib lookup and the fib lookup. So that's why we have the implicit null. So whenever R4 sends the correct connected labels, it puts as implicit null. Implicit null. That means it's telling R3. It's telling R3 whenever you get a packet for 44444, you don't swap it, you remove the label. Remove the label, okay? This process is called penultimate hop popping. You will see a pop in this R3. I'll show you. You'll see a pop, and you'll see an implicit null here for R4 for the 4444 route. Okay, and likewise you will see a implicit null here or R1 for 1.1.1.1 and a pop for 1.1.1.1 on R2. Okay guys, so it's been, I think, a good explanation. Hope you understood, and let's do the practicals. Okay, so now we have R1 and R4 are they are reachable to their loopbacks, right? So from R4, if I ping 1.1.1.1 source of loopback 0, right, I'll be able to ping. So now to enable MPLS, what we do is simple steps. We enable MPLS on the interfaces that are connected to the neighbors, right? Likewise, like we enable the routing protocols, right? So let's do the configure MPLS on the core routers. Okay, so let's begin with R1. R1 needs to run MPLS. Okay, so for MPLS also we will do one thing. We will keep the router ID static, or else it gets assigned by default. So the router ID is like the router ID of the routing protocols, right? So the selection would be same, that is the highest loopback is preferred first, and then if you don't have a highest loopback, the highest physical interface having the highest IP, right? The highest IP address on the physical network if that is active, or else number one that is preferred is the static container. So we'll statically define mpls. I think this is ldp or mpls label or router id. I'll check the command. Let's check the command. I think it's ldp or a label something. Enable config t mpls ldp router, yeah, ldp router id. So this is ldp router id as loopback 0. So I'll keep all the uh, router ids for loopback 0. Next what we'll do is mpls label range. So I'll keep the range, that range is begin from 16 to millions, right? But then I'll keep the range on R1 limited to 1000 to 1999, and on R2 2000 to 2999, on R3 3000 to 3999, likewise on R4 4000 to 4999. So MPLS label range 1000 space 1999, right? Then MPLS what next? Oh, you want to change the protocol? You can do by MPLS label protocol, I guess. Label protocol, and you'll see two options, but we'll use LDP, right? So I'll show you on R1 again. So if you see label protocol and hit a question mark, you have two things, and default is what? LDP, right? So we will use LDP only. It's not required to put this command, but yeah, I'll just keep it for fun. Okay, done. And then I need to go to the interface. It's really easy. Interface Ethernet 0/0 and say MPLS IP, and done. That's it. So this was for R1. Likewise, we'll do for R. Okay, I need to paste this, and we'll change this to R2, and R2 needs the range from 2000 to 2999, right? And also the Ethernet once E0/1 has MPLS, and R3 also copy. R3 will have 3000 to 3999. This is R3, and likewise same. And I'll go to E00 or R4. So R4 would be this thing. R4 label range should be 4 to 4999. Yeah, so let's start with R1. R1, I'll copy this and go to R1 and back, and like this. Okay, config T was already there, and right. Okay, then I have and right. Sorry, I'll copy R2. Okay, done. Should have a neighbor with the R1. Neighbor should come with R1. Okay, I didn't enable MPLS actually. So enable. I was just thinking that what happened. Okay. So yeah, I can see the neighborship comes up, and this should not be here. It should be here, right? So next is R3. R3. Let's copy R3. Go to R3. Okay. Paste it there. R3 is done. It should come up with 222, right? And then I have R4, right? So I'll copy this and this, and then paste it on R4. So R4 goes here, and right, and I have neighbors. So now let's check. It's show time, huh? Let's go to R1 and show MPLS LDP neighbors. So I have neighborship with R2, and it's using the router ID as the loopback that I said, right? And my local router ID is this. And okay, yeah, one more thing. and this MPLS, right, it runs on TCP. It uses TCP 646 port number. Okay, TCP 646 is the protocol number that it uses. Okay, so one more thing that I remembered after looking onto the output here, right, TCP, you can see my destination is 646, source of port is always random, and then this is the state, and Ethernet source is my 2 Ethernet 00, source IP address this. So the connection was created from R2, initiated actually. Address bound to pair is 2 and 2 and 222. So all three addresses, right? Let's see for R2 how many neighbors it has. So how many neighbors should R2 have? MPLS LDP neighbors. It should have two, right? R3 and R1, right? So it has R1, it has R3. Nice. So we can also see the LFIB, right? How can we see that? Show MPLS forwarding table. That is the LFIB. So I said, right, R2 will have a pop. So it has a pop for 1, right? And also for pop for 3, because 3 will generate implicit null, because 3 has 3 directly connected. So it will send implicit null to R2 and implicit null to R4. So on R4 also you will see two implicit, what do you say? You should see two pops. Let's check on R4. Show MPLS forwarding table. So you see pop for 23.3 and pop for this. A local label for R3. You can see, right? Pop for R3. That's what I said. And 23 is directly connected, so that means okay. That is my what do you say? This thing 23. So for R3 will also generate an implicit null for 23, right? Directly connected. Likewise, R3, R2 will have pop for this network also. You can see, right? Okay. So this is the LFIB, which has the next hop and the outgoing interface defined, right? So and from show IP sef it will get the layer 2 MAC address rewrite, right? And also if we have show up, so you have the L2 rewrites here, right? For on R2 you have for 23.2 and 12.2, right? So you have this as source, this as destination, this is your source, this is your destination, sorry, source, destination, source, destination. Dot 2 is the source, right? It's my locally connected neighbor, and this would be the MAC address. So like this you can see the labeling is happening, right? So let's check what's happening for. So on R1 let's check for 4.4.4 show IP MPLS, sorry, show MPLS LDP. There's another one is binding, so you can see what labels have been assigned to what routes. So you can see for 1111 I have an implicit null, and that remote that I'm getting from 222. 2 is also sending me a label for 2000 for 1.1.1, but 1 is connected directly to me, so that is a loop. And LDP doesn't care about loop, right? That needs to be taken care by the IGP that is running inside, right? That is for our case is EIGRP. So you'll see this, don't worry about that. And then you have 2222, that is the R2's loopback. For that I am generating a local label of 1000, and then I'm getting a remote label of implicit null from R2. Obviously that is a directly connected on R2 is directly connected, so it's sending to R1 as implicit null, right? Implicit, okay. So this is sent by implicit null. right? This is directly connected. For R2 it's sending to R3, R1 sorry. R1 gets as implicit null, but then it will generate a local label, right? Local label of what? It's generating a local label of 1000. So you can see, right, 1 to 1999 is R1, right? You can just see. And then again on R1 I can see I have, okay, let me just do this. On R3, okay, for 3333, okay, for 333 that means this. So I will not have implicit null. So for 333 I'll generate a local label that's 1002, and I'll get a remote label from R2 that should be in the 2000 range, right? So that's, and then 192.12 is my directly connected, and I'll send an implicit null, and also I'm getting an implicit null from R2 obviously. For 23 I'll get implicit null from R2, right, and I'll have it locally generated this. And let's see for 4. Let's see for 4. I'm binding 4 dot, if I don't know, let's try this. No, it's not running. Let's try this. No, let's try with the 255.0 dot, no 255.255.0, this one. No, let's try /8. I think that would be the one, because we configured as /8, right? Yeah, so I have. So let's check this one from R1. If I send the traffic to 444, what's happening? So my local label is 102, and it's sending to remote as 202. So for, let me grab my pen. Okay, so this is exciting. So for R1, what's really happening is R1, when we create a ping, right, for 4, okay, for 44444, going from 11111. So this is the reverse, right? So we should be getting. Anyways, so destination is 4 and source is 1. So what I'm doing, I'm attaching a label, right? I'm attaching a label. Local label is 102, but no, I don't need that. I need the remote label. So I'll be sending as 2002 to R2. I'm sending this to R2. Okay, let's check on R2 what's happening on R2. What's happening on R2? Yes, R2. Yeah, show, same command, show mpls binding. What was that? Show mpls ldp, right? Binding 4.0.0.0 Uh-huh. What was the command? On R1, right? No. Right, on R2, okay. On R2, now I see that the remote, what was the one that I sent from R1? Let's click here. So on R1, I sent as 202. Now it receives as local label 202. Going for R44, right? I need to swap it with 303, not with 1002, because this is not the, this is loop, right? So this will be taken care by the IGP, and we have to swap. R2 does what? It does a swap and change the label from 2002 to 3003, right? Okay, then it is received on R3. Let's go to R3. R3 will also do a swap. Let's go to R3. Here's R3. Okay, R3, yeah. Let's try. So same command here. So now that R3 has received a label of 303, what it is going to do? 3003, right? It is going to send as, okay, so it has received as 444. It has received from 444 as implicit null. So what it needs to do is, it needs to do a pop. PHP penultimate hop pop, right? So you can see that in the forwarding table. Show mpls forwarding table, right? So pop is for 44444. So whenever you get something with 3003, this one, you need to pop. You need to pop, right? You need to pop. You can see. So it pops out the label, and on R4 it's received as local this IP packet. Show mpls forwarding table. For 44444 you'll not see any labels. See? Alright? Because that is directly connected. So it will go into show IP route, and I'll see that that is directly connected, and the traffic likewise the reply will be like that. Okay, so hope you understood this, right? So next is the ISP, right? How ISP uses this thing. So I'll just keep this video uh, limited to the MPLS basics, and I'll create a new video part 2 wherein I will show the MPLS ISP use cases, right? Okay guys, hope you liked my video, and please do like my channel and subscribe to my channel, and happy learning to you guys. Bye.